Hi everybody, this video is on radicals and simplified radical form. The radicals we will be dealing with in this case are square roots. Could have a little 2 here saying square roots. There is such a thing as cube roots. The cube root of 27 is 3, but we won't be going there today. We're dealing today with square roots. You won't have to write this 2. It'll just be understood. If you have this radical sign, it means square root. Some of the times we're working with numbers that are not going to be radicals, in other words, numbers that are perfect squares. These are really tidy numbers that work well with radicals. The square root of 25 is 5. A square with a side of 5, 5 times 5 gives you 25. These numbers you want to recognize. They're perfect square numbers. You want to recognize all the perfect squares up through say 144, and it certainly doesn't hurt to know 20 times 20, 25 times 25, a few of those. One of the first things you need to realize about radicals is that they are in fact real numbers and they behave like all other real numbers. It's just that they're a little unwieldy if you try to write them in a decimal form. If you have the square root of 25, which we know is 5, divided by the square root of 25, which we know is 5, you will get 1. This is true for any irrational number, something like the square root of 3, divided by the square root of 3. That will have to equal 1. Similarly, they can be multiplied. Square root of 2 times the square root of 5 is the square root of 10. However, if you have, just like when you have 2 times x, that's 2x. 2 times the square root of 5 is written like so. 2 times the square root of 5, some people will refer to as 2 rad 5. When working with radicals, just like when working with fractions, you always want to have things in lowest terms. When working with radicals, you want to learn to always put the radical expressions in their simplest form. To do this, you must look at the radical and look at the factors of it. For example, 10. 10 has factors of 2 times 5. The square root of 2 times the square root of 5 is equal to the square root of 10. Since 5 and 2 are not perfect square numbers, this is already in simplified radical form. The square root of 12 is square root of 2 times the square root of 2 times the square root of 3. Square root of 2 times the square root of 2 is the square root of 4. In other words, this is 2. This 4 under the radical is a perfect square. That should be pulled out, and this would be best expressed as 2 times the square root of 3 rather than the square root of 4 times the square root of 3. This is in simplest form. Even though it may look more complicated than this, it's in simplest form because all the perfect square factors have been removed from under the radical sign. Just like when you reduce fractions, you always want to pull out the greatest perfect square factor. In fractions, you always want to find the greatest common factor. In this square of 48, 48 has multiple factors. It has 2 times 2 times 2 times 2 times 3. In other words, it has 4, 8, 16 times 3. 16 is a perfect square factor. Square root of 16 times the square root of 3 is the square root of 48. In simplest form, that will be written 4 times the square root of 3. This is simplest radical form. For your homework, please simplify these 8 expressions. Remember to pull out all perfect square factors from under the radical. Things that are not perfect squares must remain under the radical, even though it looks more complicated by pulling out the items that can be square rooted under the radical. You have made it in simplest radical form.